Have you ever wondered what makes a sentence truly complete? Imagine trying to type every letter of the alphabet at least once in a single sentence. Sounds simple, right? But what if you had to do it efficiently in a programming contest? Today, we will solve a fascinating problem that tests just that. Hi! If you are new here, let me introduce myself. I'm a software engineer with 5+ years of experience, passionate about helping you solve Codeforces problems smarter. Subscribe for practical tips and skill growth. The problem we are tackling is called Pangram. We are given a sentence, and our task is to determine whether it contains every letter of the English alphabet at least once. If it does, we print yes. Otherwise, we print no. Let us go through an example to understand the problem. Consider the input, A520 12 or 2 small word. Here, the given sentence is 2 small word. Converting it to lowercase, we get 2 small word. Checking the unique letters in this string, we see that it does not contain all 26 letters of the alphabet, so the output is no. The problem constraints are quite manageable. The length of the string is at most 100. Checking for 26 distinct letters is an O of n operation, where n is the length of the string. This makes our approach efficient. Approach to solve the problem. One simple way to solve this problem is convert the input string to lowercase so that we treat uppercase and lowercase letters equally. Convert the string into a set to extract unique characters. If the length of the set of characters is 26, print yes, otherwise print no. Let us manually test the approach with the first example. Input 12 2 small word. Step 1. Convert the string to lowercase, to small word. Step 2. Extract unique characters. T, O, os. A, la, justi, D. Step 3. Check the count. There are fewer than 26 unique letters, so we print no. Code. Explanation. Now, let us walk through the code. Read the length of the string. Convert the string to lowercase. If the length of the string is less than 26, it cannot be a pangram. Convert the string into a list of characters. Convert the list into a set to get unique characters. Check if the set has exactly 26 unique characters. Solution complexity, want. The time complexity of this solution is O of n, where n is the length of the string. The space complexity is O of 1, because the maximum possible unique characters in English are fixed at 26. By implementing this approach, we successfully pass all test cases, ensuring correctness and efficiency. Just like crafting a perfect sentence requires all the right words, solving a programming problem requires the right approach. The next time you see a problem that asks for completeness, think about sets and uniqueness. It might just save you time. If you found this video helpful, do not forget to like, share, and subscribe. Your support helps me create more content to sharpen your problem-solving skills. So, can you write a perfect sentence containing all the letters of the alphabet? Try it in the comments. Until next time, happy coding!